Hi, my name's Oliver Rue, and I'm a software engineer at Bloomberg in New York City. And I'm here today to talk to you about a tool my team built and some of the design that went into it. Today, we'll mostly be discussing REST APIs, CLIs, and API documentation. But before we do, I want to make you aware of some prerequisites. To follow this talk, it'll be helpful to have a basic understanding of what a REST API is. The example code shown here is a basic implementation of a REST API endpoint in FastAPI. But when you see something like this, just know I'm talking about an API endpoint in general. For example, this endpoint is used to get information about servers. It uses a get method, and its path is /device/compute/servers. It'll also be helpful to know a little bit about CLIs, or command line interfaces. When you see this classic green text on a black background, just know I'm talking about a CLI. And finally, we'll be discussing API documentation. I don't expect you to know the intricacies of the OpenAPI spec, but when you see something like what's shown here, know I'm referring to API docs. With that out of the way, let's get started. So at Bloomberg, I'm on a team that builds automation to make our infrastructure more reliable, scalable, and efficient. Without getting into too many details, a while back we were tasked with building a new tool. Its purpose was to unify the existing tools that our operations teams use, and in doing so, increase repeatability and efficiency. Now, for the tool set, we knew we wanted one API to host it, but we also needed a CLI for individuals to interact with it. To achieve this, there's a fairly common pattern that you might be familiar with. On the left here, you have a REST API with various methods, paths. It speaks JSON and is designed to be interacted with programmatically. And on the right, you have a CLI, made for human interaction, and it translates between the REST API operations and more human-friendly commands, syntax, and output. Usually these applications are tightly coupled, and the CLI is purpose-written specifically for the latest API spec. However, from past experience, we knew that this design presented a couple challenges. We knew our API would have quite a few operations. It might indeed never stop growing depending on the requirements of our infrastructure. While building a tightly coupled API and CLI might be easy at first, keeping the two in sync can be cumbersome as the project grows. Now let's talk about why. So a tightly coupled API and CLI is a simple and straightforward approach. The API is for programmatic access, the CLI is for human interaction, and CLI code translates between the two. But when an API and CLI are tightly coupled, every time you modify one, you likely need to modify the other. You also need to continually maintain two separate code bases with different automation, deployments, and team knowledge. Plus, API and CLI versions can get out of sync and often require you to synchronize your deployments to avoid compatibility issues. It was at this point that we had an idea. We were already planning on maintaining good API docs for other API clients using the OpenAPI spec. So what if the CLI commands were just based on the API documentation? With this model, the CLI would generate its commands by simply reading the docs every time it starts. But what are the advantages of this approach? So when your CLI is auto-generated, new features and fixes only require an API change. Because of this, the CLI and API can never get out of sync, and you avoid a bunch of the issues we just discussed. However, it's a bit more complex. And it should be noted that with this design, you still have two code bases and need to deploy the API and CLI separately. But the advantage comes from how this scales over time. In the beginning, the CLI and API will likely both be getting changed very frequently because they're under active development. But when the CLI matures, the API can still get continual updates with code fixes, new features, etc. And the CLI should hopefully only require, minimal maintenance. Effectively, at a certain point, you can stop deploying the CLI and continue changing the API, but the CLI gets updated for free. So we put together a first draft with simple one-to-one mappings between the API and CLI. API paths would map to space-separated CLI commands. Each API parameter would map to a single CLI flag, and the CLI would just print the JSON API response. We weren't the first people to think of something like this. It's been done a couple times in the past. You can just Google it or ask your favorite generative AI to do it for you. So let's look at this scheme in a little more detail. Here's a sample API endpoint that's used to list all the servers the API knows about. It uses a get method. Its path is /device/compute/servers, and it takes an optional cluster_name query parameter to filter results by cluster. And it responds with JSON containing a list of found servers. Now, if we were to naively generate a CLI command from this endpoint, it would look something like this. To use it, you need to fully type out get device compute servers, specify your cluster with the --cluster_name flag, and you get back the HTTP status code and this beautiful JSON blob in response. Unfortunately, if you can't already tell, this scheme leads to a bad CLI, and it is not much better than just using curl. So we realized that simply bolting the API and CLI together with some simple mappings was not going to work. Doing so created a really poor CLI user experience. The problem is that good APIs and CLIs are designed for very different purposes. APIs are made for programmers writing computer code, but CLIs are fundamentally a human interface. The underlying issue was that we were trying to map API concepts to the CLI domain. But REST API paths were never meant to be typed CLI commands. API parameter names were never meant to be typed CLI flags. And usually API response data is not meant to be consumed raw by humans. As we developed our first draft and we kept running into these issues, we tried to think of different ways to make the auto-generated CLI more human-friendly by changing the API. Maybe we have shorter API paths so the commands are easier to type. Maybe API path parameters could always become positional arguments on the CLI. We had a couple more ideas like this, but ultimately we were looking at it in the wrong way. The end result would have been a bad API, a bad CLI, or both. If our CLI was going to auto-generate its commands from the API, we needed a translation layer to bridge the two. So then it occurred to us, maybe we can include this translation layer in our OpenAPI docs. The docs already contain all the basic information a client needs to use the API, so why don't we include a little additional information on how to define the CLI interface to the API as well? Let's discuss how to do this. So one problem we saw was that typing out long API paths as a CLI command is a lot of work for a human and a very poor CLI experience. Ideally, long API paths could be abstracted to succinct, intuitive CLI commands. So why don't we have the docs just define a CLI command for an API endpoint? Then you go from this to this. Shorter commands mean less typing, but they're also cleaner and easier to understand. Another obvious problem we saw was the API output formatting. REST APIs often speak JSON, but JSON is not very human-friendly. You can see that here. Even if we pretty printed this JSON, it's not going to be easy for a human to read. So what if the docs included instructions on how to translate the JSON into something easier to read? Then you can go from this to this. And to accomplish this translation, but still keep the CLI completely decoupled from the API, we use Jinja templates. If you're not familiar with Jinja, it's a relatively simple templating language that has widespread use in the Python community. So the docs would contain a server-defined Jinja template for each API endpoint, and the CLI simply has to pass the API response through the template to get the human-friendly output. There's a little more nuance to the output formatting problem, though. We observed that CLI users often wanted the ability to display the same essential data, but in slightly different ways. For example, here, instead of the table, what if the user wanted the output as CSV? Well, it would be silly to have multiple virtually identical API endpoints whose only difference is how the output is displayed to the CLI user. But we could have multiple Jinja templates for a single API endpoint and give the user a way to choose between them. We could have one template to display the output as CSV, triggered by the --CSV flag. Maybe another template just to display network information, triggered by the --net flag. And of course, all these options would be shown to the users in the command help text. You also might notice that --JSON flag there too. That gives the CLI user the option to display the raw JSON output from the API and pipe it to a file or JQ or something else. Another issue we noticed involved how arguments were passed to the API. Originally, we just planned on having one CLI flag per API argument. However, take a look at this getServer command generated from the API endpoint code shown to the right. The --hostname flag isn't really buying us much. There's only one required argument to the API endpoint, and it's just more for the user to type. So why not include the ability to just make arguments positional, like this? That's a relatively simple change, but it definitely makes the command more human-friendly. Staying on the topic of arguments, we noticed another unfortunate consequence of mapping API arguments directly to the CLI. It's often handy and good code hygiene to have descriptive variable names in your code. Here on the right, we have an API endpoint that collects logs for a given server and saves them to a file system. To represent the log file destination, we have a descriptive variable called destination_filepath. While this variable name might be helpful to programmers, it's an awfully long and cumbersome CLI flag to type, not to mention that the use of underscores in CLI flags doesn't follow POSIX conventions. So why don't we have the ability to specifically define the CLI flag and short flag used to represent a given API parameter, like this. To specify destination file path, now you can use --destpath or just -p. Again, little improvements like this go a long way in improving the CLI user's experience. The final problem we observed with API and CLI argument mapping was that sometimes arguments just couldn't easily be represented using simple strings. What if the CLI command needed to upload a local file? What about Boolean CLI flags whose simple presence represents true? What about list arguments with a fixed or dynamic number of entries? We knew we needed to build a dynamic system to represent unusual API arguments on the CLI, but in a human-friendly way. All right, now that we have a clear understanding of the problem, it's time to implement some solutions. While we use many of the great open source projects you see here, we're going to primarily focus on FastAPI. If you aren't familiar with FastAPI, it's a great open source web framework for Python. While there are numerous good reasons to use it, one feature we love is the support for automatic OpenAPI doc generation. Here on the left, we have a simple FastAPI implementation with 2 endpoints. With just this code, FastAPI automatically generates the OpenAPI docs you see on the right. However, what we see on the right is not the actual documentation itself, but just a pretty rendering of it. And the actual documentation is defined in JSON and looks like this. This JSON is the actual OpenAPI spec, which contains all the information a client needs to know. And as you can see, the JSON contains a section for each path on the API. This is what our CLI will be parsing to generate its commands. So let's take a closer look at the OpenAPI JSON. Here on the right, you can see the OpenAPI JSON generated for the getHello endpoint on the left. It contains a summary, a description of parameters, and a little bit more information than I left out for simplicity. For our use case, we need to define extra information for each API endpoint so the CLI can configure itself. So we just added an extra section like this. Each endpoint gets a CLI section that can define things like the actual CLI command, the Jinja formatters, and more. Fortunately for us, FastAPI has a neat keyword arg called OpenAPI Extra that allows the user to embed arbitrary data in the OpenAPI spec for an individual endpoint, and it's used like this. You just include your arbitrary object in the endpoint decorator, and it's automatically nested in the generated OpenAPI spec. Now, we could just shoehorn a huge dictionary into every endpoint decorator to define the entire CLI spec, but that would be crude and not very readable. So instead, we decided to implement our own child class of the FastAPI API router, but we added some additional arguments to include the CLI specification as well, something like what's shown here. And with that, we can now define our API endpoints and associated CLI commands like this. We write our endpoints just like we normally would in FastAPI, but with the option of specifying a CLI command in just a few extra lines. Of course, you still need to define the specific Jinja templates, but we often found that they could be reused between different endpoints, and they could live somewhere else. Well, this is all you need to describe the CLI command for an endpoint. We still haven't covered how we'll handle CLI arguments. FastAPI already offers a rich set of tools to define API argument behavior. Here we have the query class to define a query parameter, and the field class to define individual fields in a JSON request body with Pydantic. There are similar classes to define other types of API arguments as well. And the information defined in these classes is also reflected in the OpenAPI JSON. Like the FastAPI endpoint decorators, it's also easy to tack on extra information. So just like the endpoint CLI specification, we use Pydantic to define our model, add it to the argument declaration, and it automatically shows up in the OpenAPI JSON where it can be consumed by the CLI. All right, so now that we have all the pieces to implement a CLI command for the API endpoint, let's put everything together. Here on the left, we have an endpoint from earlier that's used to get a list of servers. And on the right, we have a CLI command that we want to be generated for this endpoint. To implement the CLI command, all you have to add is this. That's it. Just a small amount of information, and the CLI command is generated by FastAPI, OpenAPI, and our dynamic CLI. Now that you have a good understanding of the design and implementation, let's see it in action. I don't want to bore you with more monospaced text on a black background. We've all seen enough during the conference. But I think a live demonstration is a great way to showcase the utility of what we built. All right, bear with me for a moment while I reconfigure my screen. And I hope that the live demo gods are just. Let's see. All right, I'm going to run a few things here. These top two windows, don't worry if you can't read them. It's not important. I'm just going to say what's happening there. So in the upper left here, I'm going to run something called Infra API. Infra API is just a demo API I wrote for interacting with fake infrastructure. It's written in FastAPI. It's got all those extra annotations we talked about to implement a CLI interface for it. And it's running locally on my machine on port 8001. But instead, pretending it's running in some server in a data center in Virginia. In this window, and is this readable for everyone? OK. In this window, we're going to run Infra CLI. Infra CLI is the CLI that interacts with Infra API. And it's auto-generated from Infra API running above. So it's got a couple subcommands here. Get server, delete server, new server, and list servers. If you look closely when I run Infra CLI, up here you can see a call come into Infra API. That's the CLI on start, grabbing the OpenAPI JSON, parsing it, and generating its commands. So let's see what Infra CLI can do. Infra CLI list. So we've got the list servers command. Let me show you the help text. It's used to display a list of known servers in the system. It's got a -- cluster flag to only show servers in this cluster. And it's got a couple formatters. A JSON formatter to display the raw JSON, a CSV formatter to display the output in CSV format, and a net -- net flag to display server network information. So if we run it like we did before, we can see our server output in a nice column-separated table. If we specify the -- cluster flag, we can see just the servers in that cluster. If we specify the CSV flag, we see that same output, but in CSV format. So we've got our list server command, and we got some feedback from our users. They say, first of all, list servers is too much to type. Instead, we just want to type ls servers. OK. And they also say you have some horrible typos in your description, and you should fix those. OK? So let's see what it takes to fix those. So I'm going to open up the source code for Infra API here. It's not important that you read all of it. I'm just going to point out a couple key things. So here on line 72, yeah, you can read that. Here on line 72 is where the decorator is to define the API endpoint behind the ls servers command. You can see the path here, /device/compute/servers. Then on line 76, we have the CLI spec, just like what we talked about. And within the CLI spec is how we define the behavior of our CLI. So on line 77, we've got the help text with our typos in it. So let's fix those. All right, and then on line 78, we have our command, list servers, and they said they wanted it to be ls servers. Save. Exit out of that. If you were looking closely above, the API restarted. That's because I have it configured to automatically restart when its source code changes. But picture instead you cut a branch, you made a PR, you merged it, you deployed it, it went through CI, and you deployed it to some server somewhere. So we're going to run Infra CLI again. Now list servers is ls servers. And if you look at the ls servers help text, no more typos. So we get a little bit more feedback from our users. They say, this CSV flag is great, but what we really want is a TSV flag, or tab separated values. OK, let's see what it takes to implement that. Go back to our source code. We're going to open a file called format.py. This is where we just define all our formatters. So on line 121, we have our CSV formatter. TSV is a lot like CSV, so let's just copy that. We're going to change it. We'll change all our commas to tab. We're going to change our flag from --CSV to --TSV. Why don't we add a short flag that's just a -T. And then, of course, our description should be display servers in TSV format. There's two more quick things we got to do. In our formatter section, we have to add the TSV formatter for the API endpoint. And then we have to import it. Save. We saw our API restarted, so that means it worked successfully. And let's see the command now. LS servers now has a --TSV flag. And if we specify it, we can see that same output, but in TSV format. To recap what we just did, we changed 3 different types of CLI behavior just from the API code. The CLI code was completely static the whole time. All we did was change the API code and the automatically generated docs that it creates, and the CLI pulled those in. I want to show you one more quick thing. So in this window up here, we're going to run something called Meal API. It's a mock API built to interact with meal ideas. It's written in FastAPI. It's got the same annotations to implement a CLI interface for it, and it's running locally on port 8002. So let's see meal CLI. All right, it's got a couple subcommands. We'll just run meal CLI meals, and it prints out a list of meals, a lot like infra CLI. I don't want to show you anything more about meal CLI, but I want to show you what's behind it. Infra CLI and meal CLI are the same thing. They both are aliased to a program called auto CLI, where we pass them the API URL. So instead of running infra API, I could just run auto CLI, API URL, localhost 8001. And that's infra CLI. If we change the port by 1 number, change the URL, that's meal CLI. You can have one physical CLI code base that can implement any number of virtual CLIs, depending on what API you pointed out. And when you want to update your API, update your CLI, you just change your API, and the CLI gets updated for free. That's all I got.
Thank you, Oliver, for quite an informative session. So if we have some questions, there are 2 microphones on that side of the room. If you can please just walk by there, that would be nice. And also for others, the lunch might have been served in the lobby, so that's another interesting thing.
Hey, thank you for your talk. Can you hear me?
A little bit.
I'll guess it just.
That's better.
Yeah. I'm wondering, so API calls are typically very atomic. And on the CLI side, I would like to just kind of chain them together. Is it possible to kind of add just like chains of commands on the CLI without changing the API itself?
So add multiple API endpoints behind a single CLI call.
Yeah, so for example, add a server and list them.
So sort of. We've talked about that, and we haven't added it to ours yet. Basically, what we talked about is having so-called like a virtual CLI command, where I could define a CLI command in the API code, and maybe we'd have a Jinja template that says call edit server, then call list server. Yeah. And so the CLI reads that, and it reads the virtual endpoint, and then it knows, okay, I can call edit, and then I can call CLI, list servers, so that we can still keep everything defined in the API code, but the CLI behavior can change. But we haven't implemented that yet.
Okay, thanks.
Yeah.
Hi, thank you. Very cool stuff. Can you give us some details on how the code generation is working on the CLI side?
It's just pulling down the OpenAPI JSON, and then basically I'm running it. I'm using argparse. I probably should use some cooler new CLI thing. I saw a really great talk about Typer yesterday. And maybe one day we'll use that. But for now, we're just using argparse subcommands. And then there's some simple translation in there where we read the specific specification. Like for one of the arguments, if it's got a flag name that you want to use, we have to use that for argparse, pass that into argparse, then map that back to the API argument.
All right, cool. Thank you.
Sure.
Hello, thanks for the talk. It's very interesting.
Thanks.
I just had a quick question. So you were making commands shorter and arguments shorter, and that was very nice. But you were always typing infra CLI at the very beginning.
Mm-hmm.
And I was wondering, is there a way to not type that, where you like enter into sub CLI system and just LS servers is enough to do it? Like
sort of. So I think what you're talking about is sort of like an interactive mode, like you drop into a subshell.
Yes.
I didn't do that in this program. In our internal one that isn't public, we have something like that where there's a subshell, and it wouldn't be very hard to add in this. In fact, in the slide where I showed the open source projects that we use, one in there is called Prompt Toolkit, which is a really nice open source library for doing just that and creating like dynamic sort of captive CLIs. And so it's very possible, but in the program I wrote for this, you can't do it.
Yeah. What's this called again? Prompt shell?
The program?
Yeah, the open source one.
Oh, it's not open source, sorry.
Oh, sorry. Okay.
Yeah, but it's called Auto CLI, but yeah.
Okay, that's thank you.
So if the CLI like dynamically fetches the OpenAPI at startup, how do you deal with breaking changes? Like if somebody has built a script on the CLI and you do a backwards incompatible change on the CLI spec, is there any versioning or pinning or maybe like embedding a particular, because you can imagine the CLI can change independently from the endpoints, right? And all the CLI should still work.
I'm not sure I understand your question, because I think what we're trying to do is basically avoid that altogether. Like there is no CLI sort of. It's only what's defined in the API. Now, if you mean like someone wrote a script.
Yeah, exactly.
Okay. That would be up to the API writers to make sure they don't like change the command from list servers to LS servers or something like that.
Right.
But beyond that, there's no pinning on it because that old version of the API doesn't exist anymore. It's whatever the latest docs of the API are.
No, sure, but in your example where you changed list servers to LS servers, the endpoint didn't change, right? The endpoint remained the same. You only changed the CLI. So you could imagine.
I see what you're saying.
So if you did literally that change, I can imagine somebody having a script with list servers, and it should just still run because your API didn't change.
That's a great idea, actually. We probably wouldn't make a change like that once we release something publicly, but if we were, it wouldn't be hard to add like a set of aliases so that the CLI will recognize any one of those and still work.
Right.
But great idea.
Cool, thanks.
So thank you for the presentation. So we have the infra API, infra CLI, and when we will have infra chat, so you can chat with your API.
Maybe EuroPython next year. I gave this talk somewhere else, and someone asked about like shoving the OpenAPI JSON into something like a generative AI and saying, hey, generate a CLI for that. That would be pretty cool. I don't think Bloomberg would let me do that right now, but yeah, it'd be pretty cool.
Thank you.
Yeah, so I was just wondering, is it possible to include autocompletion there for the arguments?
Yeah, it could be. I didn't include it in ours in the demo program I wrote for this, but like in the talk from Typer yesterday, they had some really neat stuff to just automatically install the completions for your CLI. That would be super neat to do for something like this. But I didn't do it for my program.
Okay, good, thanks.
Hi, thanks for the presentation. If I'm not mistaken, every time that you fire a CLI command, there is a call first to fetch the API documentation and then the actual call. Could this become like a performance issue if the API becomes too large? And have you maybe considered a different approach that you only have to periodically fetch the specs, like maybe run a command once there is an update on the specs,
Mm-hmm.
and then it's somehow cast or in different mechanism? I don't know.
So for the first part, I mean, I don't think it would be a performance issue. FastAPI, as far as I can tell, generates the docs once and then it's cached in memory, and so it's just serving up a static thing of JSON, and I assume it would be lower impact than whatever API call you're doing. But in terms of caching the version, caching the docs locally on the CLI, we've discussed that. And that would be something easy to do, but then we have to deal with versioning. So we talked about like, maybe we pull down the OpenAPI JSON once and we save it locally. But then every time the CLI calls the API, it includes the API version in a header. So the API could see the CLI version and say, oh, you're behind, update your docs before you make this call. Because we need some way to automatically update the CLI when the API gets updated. So there are a couple caching schemes in there, and if it ever became a problem, we might do something like that.
Thanks. I was also referring to performance issues regarding the CLI, not fetching the documents, but actually parsing the documents every time and dynamically registering the whole functionality. I think you do this on every call, right?
Yeah. I guess if the JSON got suitably large, it could. I haven't looked at it, but I profiled this once, and like most of the startup time was importing a ton of modules on the CLI, while the parsing the JSON was just like instantaneous. If anything, I feel like performance on the CLI could be improved by doing something like what the other guy said, of having a captive one, so you start it up, and then you don't have to import all your modules right at start. But it's something we would consider doing, like saving it in a more like, I don't know, computer-friendly format and caching it locally if it ever became a problem.
Great, thanks.
Yeah.
So I think that will be the end of the session. Thank you everyone for joining here, and thank you, Oliver. Thanks for everyone. Yeah. Have a nice day.